Good day, everyone. This is Professor Friday from Macomb Community College. We're going to be talking about solving some triangles today. Now, the details for the side-side angle case are probably going to be the most important details that we talk about because this one is the one that is a gigantic pain. So, just to be clear, when we say side-side angle case, the pieces of information that we've been given one corresponding angle side pair. That is, we've either been given A and alpha, B and beta, or C and gamma. And one additional side. So if we were to actually draw this triangle out, I'll draw a picture of this triangle. There's a good generic looking triangle right here. So anytime we label, alpha is across from A, beta is across from B, and gamma is across from C. So the pieces of information that we have been given are going to be a corresponding angle side pair. For the purposes of this picture, we'll just say, let's let that pair be A and alpha, and then we'll be given one additional side, and we'll just say, for the sake of argument, that that is going to be the side B. Now, the questions that we're supposed to ask ourselves when we are taking care of these triangles, solving these triangles, is first off, do I have two angles? And the answer is no. And the second question you're supposed to ask is, do we have a corresponding angle side pair? And the answer is yes. We do have a corresponding angle side pair, and we have this additional side B. Now, according to that, we're supposed to use the law of sines. Now, because we have a corresponding angle side pair in the form of A and alpha, we would set this up as sine of alpha over A is equal to the sine of beta over B. And the things in this equation that we know the value of alpha, we know the value of A, we know the value of B, which means that we are going to wind up solving for the sine of B. And if we were to perform that algebra, we would get that the sine of B is equal to B times the sine of alpha divided by A. Now, at this point, normally what we would do is we would apply an inverse sign to both sides, and we'd say whatever we get for beta, that's our final answer. Unfortunately, there are some additional restrictions on beta that need to come into play. Now, the biggest restriction that comes into play on beta is simply the unit circle. So, let's say for the sake of argument, we have an acute angle that we refer to as beta. There would be a corresponding pair on the unit circle, corresponding ordered pair on the unit circle that we'd refer to as x and y. Now, that would tell us that the cosine of beta is equal to x, and it tells us that the sine of beta is equal to y. However, we also know, because all students take calculus, that it is possible for there to be an additional angle here. We know that the three sides of a right triangle have to add up to 180. It means that angles could potentially be acute or obtuse. I missed my target. Well, then I'll make my target bigger. There you go. So there is another possibility for our angle beta, and that would be 180 degrees minus whatever it is we just calculated for beta. This is due to the fact that if we were to consider the ordered pair associated with this angle, the ordered pair is in quadrant 2, so x would be negative, but y would still be positive, which tells us that the sine of 180 degrees minus beta is still equal to whatever that value was that made it work over in quadrant 1. So, with that in mind, when we have the side-side angle case, if you calculate your angle beta, and it is possible, when you calculate your angle beta, you should also calculate the angle 180 degrees minus beta, just to see if it will still possibly work. So we had this quantity on the previous page, and we said this. I'm going to recopy this down onto this page since we're going to do a little bit of work with it. Sine of beta is equal to B times the sine of alpha all over A. So according to the law of sines, we calculate this quantity. Then we have four different possible cases. The four possible cases that we get. If we get that the sine of beta is greater than 1, then we know right away that this ratio is outside the scope of what the unit circle can possibly give us. Then there is no triangle possible. No big deal. I told my class that in this case you should think of a T-Rex making a bed, because now your picture of a triangle looks like this. You got your side down here, your side here, then you got a side here that just can't reach all the way down. So I say, picture a T-Rex that's reaching down to make a bed, and it just can't reach. Second possibility, this doesn't happen too frequently, but when it does, it is an absolute gift. If the sine of beta is equal to 1, then the only possible angle on the unit circle that we could be talking about is where the y-coordinate is equal to 1. That is a good old-fashioned 90-degree angle. Now for the 90-degree angle, this means that there is one triangle possible. And that beta is equal to 90 degrees. This is a pretty awesome case. Now, the third possibility, this is where the fun comes in. And by fun, of course, I mean words that start with F and then are followed by a U. If the sine of beta is less than 1, then you have to test both beta and 180 degrees minus beta. It is a 100% guarantee that whatever you get for beta, and based on our formula up here, it looks like we would be getting that beta is equal to the inverse sine of whatever this quantity here was, b times the sine of alpha over a. Now, quite frankly, the procedure hasn't changed at all to this point. The only additional thing that has taken place is that we have to calculate an inverse sine here rather than going some other route. Now, it is not always a 100% guarantee that 180 degrees minus beta does work, but you still have to test it. That is, calculate the angle and say, if this works in the calculation of alpha and gamma after that, well, alpha will be given to you. So if this works with the calculation of gamma, then it forms a second triangle that is possible. In my next video, we'll investigate that case because it is just so much fun to try out.